look at number 6. Again, we're comparing fractions and mixed numbers and improper fractions. So a reminder that it's easiest to compare fractions, mixed numbers, when we have a common denominator. So if we look at A, we're comparing 2/3 to, let me change my pen size here. Okay, 2/3 and 5/6. We don't have a common denominator. We're dealing with thirds and sixths. So to easily compare these two, you will want to make equivalent fractions. So we have a denominator of 5, and we have a denominator, not a denominator of 5. We have a denominator of 6, and we have a denominator of 3. Okay, so denominator of 3, denominator of 6. We're going to list the multiples of 3, list the multiples of 6, until we find the lowest one they have in common. And I see the lowest one they have in common is 6. So now I can make equivalent fractions with a denominator of 6, and it will be easy to compare those two fractions. So I don't need to do much with 5/6 because it's already built in 6. So 5/6 would just stay 5/6. But what did I multiply 3 by to get to 6? 2. So whatever I multiply the denominator by, I have to multiply the numerator by. So 2 times 2 is 4. So the equivalent fraction for 2/3 would be 4/6. Now do you see how easy it is to compare 4/6 and 5/6? We can clearly see that 5/6 would be greater than, or if we're reading it as the number sentence here, 2/3 is less than 5/6. 2/3 is less than 5/6. All right, let's look at B. It says 1 1/2 compared with 9/6. Okay, so here we have a mixed number and an improper fraction. So I want to get them both as an improper fraction in order to compare. So I'm going to look at 1 1/2. Remember, this would be one whole and then half of another whole. So to turn it into an improper fraction, I can look to see how many total halves I have. So here's a half, here's a half, here's a half, which would be 1/2, 2 halves, 3 halves. So 1 1/2 written as an improper fraction would be 3 halves. Another way we looked at that in class is by saying we can take the whole number times the denominator plus the numerator. So 1 times 2 is 2, plus 1 is 3, and we're dealing with halves, so it would be 3 halves. Okay, so now I have 3 halves compared with 9/6. Again, we can't really do anything unless we have common denominators. So let's find the common denominator between 2 and 6. We list the multiples of 2. We list the multiples of 6. We find the lowest one they have in common, and then we make equivalent fractions with that as our denominator. 9/6, not much I need to do because it's already built in 6. So here are my 9/6. And then I ask myself, 2 times what gets me to 6? 3. So whatever I multiply the denominator by, I multiply the numerator by. 3 times 3 is 9. And so the equivalent fraction for 3 halves would be 9/6. So is it pretty easy to compare now? 9/6 compared with 9/6. We can see those two numbers are equivalent or equal. Let's look at option C, 4/12 compared with 2/6. Again, we don't have common denominators, so we're going to want to make this going to make equivalent fractions in order to compare. We have a denominator of 6 and a denominator of 12. So we list the multiples until we find the lowest one they have in common, which happens to be 12. And now we can make equivalent fractions. 4/12, 2/6. Both need a denominator of 12. Not much we need to do with 4/12. It's already built in twelfths. But 2/6, we need to make an equivalent fraction. So 6 times what gets me to 12? 6 times 2. Whatever we multiply the denominator by, we multiply the numerator by to make equivalent fractions. So 2 times 2 is 4. And so the equivalent fraction for 2/6 would be 4/12. And now when we compare, we can see that 4/12 and 4/12 are equal. So that tells us that 4/12 and 2/6 are equal. Now some of you might be saying, oh, well, Mrs. Perkins, I saw that really all you had to do is divide the numerator and the denominator by 2 to simplify, and that would have gotten me to 2/6 as well. And I would say, you are right. So this is an example of how you could also simplify. And the last answer choice, 3/4 and 3/12. Again, before we can compare, we have to have equivalent fractions. We need to have the same denominator in order to make an easy comparison. Now, I will say, this is another one where if you just take a minute to visualize it, right? If you picture a whole divided into 4 equal parts, and here's 1 part, 2 parts, 3 parts. So there's what 3/4 would look like, okay? And then if you're going to divide a whole into 12ths, and I'm not going to do it exactly here, but just picture, if you will, here's 4ths, here's 8ths. It's not going to be equal, but I mean, these are going to be little pieces, right? 12ths. And if you picture 3 of those, 1, 2, 3, it's going to be nowhere near the size that 3/4 would be. So if you just think kind of visually and logically, we know that 3/4 is going to be greater because 12ths are such small little pieces. And again, I know this isn't exact, but it just helps you to kind of think through visually or logically, because 12ths are so much tinier, those 12ths pieces are so much tinier, there's no way that 3 of those tiny pieces would be the same size or greater than 3 out of 4 big pieces, okay? But let's look at it mathematically too. So we know in order to compare, we need to have a common denominator. So 4, 8, 12. We can see that the least common multiple is 12. So let's make equivalent fractions. 3/4 with a denominator of 12. 3/12 with a denominator of 12. Well, not much we need to do with 3/12. It's already built in 12ths, so we're good to go there. But 3/4, 4 times what gets us to 12? 4 times 3. Whatever we multiply the denominator by, we multiply the numerator by. So 3 times 3 is 9. So 3/4, the equivalent fraction would be 9/12. And now when we compare, we can see that 9/12 is greater than 3/12. And so we were right. 3/4 would be greater than 3/12.